welcome everybody. My name is Gene Jones. I'm Executive Director for an organization called the Southern Waste Information Exchange. We're a nonprofit organization that kind of acts like a matchmaker. I put waste generators in touch with waste users to encourage recycling and reuse of waste materials. The other thing that we do as part of our services is to put events on like this. So we run this event. We run an event that starts on Wednesday here, Agricultural Plastic Recycling Conference. We also do the Southeast Recycling Conference and then a couple of remediation conferences. I'm not going to go into great detail here because this is our pre-conference workshop, so I'll make some additional comments tomorrow morning. I'm going to go ahead and get us started and turn us over. This is a pre-conference workshop to focus on a number of different types of technologies and presentations, all in the realm of the waste conversion arena. Our moderator is going to be Norbert Barszczewski, who is president of JP NetQuest. I've had the opportunity to work with Norbert at events like this for almost 20 years now, going on that anyway. We've done events in the US, in Central and Eastern Europe, and London, and a host of other places. So I'm going to turn it over to him, and we're going to get going right away. So, Norbert.
Thank you, Gene. It's actually been over 20 years, almost 20 years. But what a great 20 years it has been. Thank you, Gene. Welcome, everybody. Good afternoon. We're going to go ahead and get started. We have David and Tim on the back facilitating our audiovisual equipment. We have Taryn at the back also. She will help us with Q&A. So if you will have a question, she will pass the microphone to you. And let's go ahead and get started. Our first speaker is Dr. Monem Alyaser, who is the Chief Executive Officer of Enventix, Inc.
Thank you, and good afternoon, everyone. I'll be talking about the thermal conversion of SRF, solid recovered fuel. But my presentation will be really in general about how the concept of maximum recovery, because conversion of SRF is one component of dealing with the waste, as many of you know, that the waste is made of several components that need different technologies, different treatment. There's no one treatment that fit all. So, but the reason why the SRF conversion, thermochemical conversion is important is because it is the remaining component in terms of the technology stream to close the loop on the recycling, whether direct recycling or chemical recycling. So I'm going to go through a quick review of what are we dealing with in terms of waste and waste management in the US as an example. As you know, we produce around 300 million tons per year of municipal solid waste. Out of that is about 40% organics, food. That proportion really increases outside of the United States, specifically in developing countries. It could go as high as 70%. And the amount of recyclables decrease in developing countries. Me, as part of a company that develops solutions for waste, our objective is to develop solutions that are global in nature, because waste is a global issue, it's a global problem, not just from the perspective of value recovery, but also from global climate change issue, ground and greenhouse gas emissions. So as you can see, if you look at this composition of this waste, only about 20% or so is recyclable. Cardboard, plastic containers, and bottles, metals, maybe glass, but 20% out of the total is really maximum. We can reach about close to 30%. And in terms of recyclable directly, 40% are organics, If you could, well, if you see here, when we see 40%, it's only 21.59% or so, 22% is food. But we got wood as part of that, we got yard trimming, and we have, so that, when you add it all together, it's about 40%. In terms of paper, anyone who deals with paper recycling and so on know that a lot of paper is not recyclable. You know, dirty pizza boxes are not recyclable. All of the packaging material is not recyclable. You can't just go send it to a paper plant and recycle it. So what do we do with it? And a lot of it is commingled. So how much do we send to the landfill? We send pretty significant amount, about 50% or so, with all of the recycling, all of the organics, all of the waste to energy and everything. Significant amount of value that is lost. Also significant amount of greenhouse gas emissions from landfill. Waste is not something that decreases, it increases with population, we know that. It doesn't matter what you do. So, what is the solution? As you know that, landfill is a business as usual in many countries, not just in the United States. And anything different requires capital investment, which in many places there's not any incentives to make that capital investments. It's waste management companies don't like to do that, don't want to change this type of business because it doesn't, in their perspective, doesn't always work. We have some proliferation of MRFs, not only here in the United States, but throughout the world. There's some adoption of MRFs. But remember, MRFs, dirty MRFs, single stream, or single stream, if you're dealing with mixed, most of our waste is mixed waste, municipal solid waste. It's like this. It comes from a bag, and it has everything. And it doesn't matter where you are, with some exceptions, maybe you can change habits of people to make them take the recyclable materials and put them in the blue box, but you're always going to have to deal with the mixed bag that has everything in it. So in order to solve that problem, we really have to use technologies which are in development and developing, and many of the big components of these technologies are here already that will allow us to sense, segregate, and separate, and able to do that effectively. So we need effective separation and materials recovery. Remember, we build MRFs that deal, if you take all of the material that is generated as waste and then recover only 20% of it. I guess that's not a big deal because we do that in mining too. We go and dig all of the rocks, crush them, grind them, and make them into fine, and then go through a series of processes just to extract a very small amount of valuable materials. However, with waste, we could do a lot more than that. We don't have to recover only 20% and then send about 80% to the landfill, where most of that material that we send to the landfill actually ends up making greenhouse gas emissions. Not only that, it has a significant amount of value that could be recovered. That value recovery should be the driving force for investment. So if we are able to recover value effectively, that would be the feed to make the investments. So when it comes to capital investment, shouldn't be deterrent, shouldn't be the barrier for adoption of new technologies and collective technologies that maximize recovery. So All of the requirements here, what you see is that we have to remove the organics, the food that comes in the bag, all of that material, and also the shoe and the brick and everything. We have to be able to do that effectively. And we have to be able to recover all of the valuable recyclables effectively, separate them. The concept that we're talking about, most of it is familiar to everybody. The MRF, many people, I'm sure here, are familiar with MRFs, material recovery facilities, which have either dirty MRFs or single stream, can accept the waste, segregate it into recyclable materials, metals, paper, cardboard, glass, recyclable plastics, and also recover the organics. What do we do with the organics? There's a lot of good examples now already using anaerobic digestion and composting. We can recover significant amount of energy as well as prevent the organics from creating greenhouse gas emissions in landfill and create compost, which in turn helps create soil amendments and improve overall agriculture. And what happens after we do that? Remember we said 20% recyclables or so, 40% food, organics. Then if we do that effectively, we're talking about 60%. Then we still have about 40% we need to take it to the landfill. And every time we put waste in a truck, bring it from the source to the MRF, and then from the MRF to a landfill, that's also another greenhouse gas emissions associated with that. Plus, we'll be throwing value into landfill. So what else can we do with that? There is, if you look at the waste, for example, here you look at the MSW-based waste, you'll find that 20% of it is non-recyclable waste paper and film plastics commingled. Pretty significant. All of the packaging materials that we can't do without, that we use for our groceries, for disposable appliances, like paper cups, plates, dirty pizza boxes, all of that. All commingled dirty cannot be recycled. You cannot even separate it. You can take a brick out of it, or you could take a piece of metal, but you cannot separate that film plastics and dirty paper and wet paper that actually is a major source of greenhouse gas emissions. That is the portion that should be thermally converted. Not the entire waste, because waste that has food, has high moisture content, should not come anywhere waste to energy. And it would be such a waste. Waste to energy plants, in general, they're based on thermochemical, technologies that are designed for economics of scale. They have to be bigger. They're hungry in order to make sense economically. But our waste is not all big. The average city in the United States produces 500 tons per day. That's the fact. We have exceptions. Big cities produce thousands of tons per day, 500 tons per day. So if we want to do a global solution that solves the problem of waste and gives us maximum recovery, we have to develop technologies and equipment that is capable of producing value at 500 tons per day, which means that only about 100 tons per day in a typical city should be converted to energy, not thousands. The rest should be recovered for value. The value is in recyclables, compost, biogas, and all of that. So when we do all of that in an integrated fashion, when it's all one project, it makes a lot more sense economically. Because when you integrate all of this process equipment together, it's the cost of operations starts to come down. The capital investment also starts to come down. The value, the overall recovery increases. The amount of money that we, and greenhouse gas emissions that we expend on moving waste around comes down. That's where maximum recovery starts to happen. So what is a MRF? Is every MRF, not all MRFs are created equal, you know. A MRF that has 50 guys standing there moving things by hand is not a modern MRF that gives you maximum recovery. But a MRF that uses optical technologies, it uses pneumatics, uses eddy current, it uses magnetics, removing all these different types of constituents of waste effectively, including MRFs that have artificial intelligence and machine learning based equipment that can actually recover recyclable materials at a higher efficiency. That's the type of MRF that we're talking about. When we have maximum recovery, and when you have maximum recovery, it makes a difference in terms of economics when you're recovering 80% and even 85% and 90%. Huge difference. And you talk to a lot of executives in the waste management industry, they tell you, oh, MRF's no good. They're just a waste of money. But that's not the attitude we should be taking towards a pretty significant and complex problem that has, as our population increases, not just in the US, and our cities increase throughout the world, is that we need value recovery. Our eyes and intention should be towards improving technologies and improving efficiency, recovery efficiency, not dismissing technologies that are in development. So what about the organics portion? We have very good examples. Already have very successful examples. One of them is the largest anaerobic digestion plant. It's built by Zero Waste Development Energy for the city of San Jose. And it's operating very well, producing biogas, exporting power, green power, biopower, and it's also producing clean compost. There are several other examples. There's another new example also for waste management in city of San Leandro. Just, I believe it's commissioned or just about to be commissioned. So there's a lot of examples. There's two important components of an integrated material and energy recovery facility. The MRF, anaerobic digestion composting. Then what else do we need in order to complete the recycling loop? We need to deal with this type of waste, okay? Because that is not organics. You can turn it into biogas, and it's not recyclable. You can go take it to plastic factory and turn it into plastics again. That's dirty, commingled paper and plastics. Wet, dirty paper. Guess what? Our waste here in the US and most waste, municipal waste in the world, after you put it through a MRF, you will find that portion has about 60% paper, 40% plastics, film plastics. What does that mean? It means that it has a significant amount of biogenic carbon. It's a biomass base. You can turn it into biofuel for carbon reduction. If you take that and burn it all in an incinerator, you're just turning it into CO2, all of it, including the plastic portion. If you gasify it and try to make biofuels from it, same thing. And you can't have effective gasification systems that work at 100 ton per day economically. That's why when you talk to people, say, well, it doesn't work. I need a big plant. Where am I going to get that waste? How many cities have thousands of municipal solid waste per day? So the solution is densification, creating of SRF, solid recovered fuel, from a resource that could be recovered within the MRF. So a MRF, could have series of equipment for further recovery, for further of that residual waste, cleaning it further from the brick, from the piece of metal, from the batteries, from all of that, and then densifying it into SRF. And that SRF could be fed into a system, a pyrolysis system, not a gasification system where it has to be shredded, it has to be fed into a gasifier like a fluidized bed reactor where cryogenic oxygen has to be used. How much time do I have? Almost done. So if we do all of that, what is the impact if we apply to all of our waste here in the US? This is the impact that we can expect. Right now, this is the amount of waste that we send to a landfill. Okay, this is how much we do combustion with waste to energy. This is how much composted and how much we recycle. 25%. It's really actually questionable, but if we apply all of these technologies, we can reduce landfill from this amount to less than 13%. Again, these numbers can be up and down depending on which technologies you deploy. And the amount of energy recovered can be significantly increased, and it is bioenergy. It is biomass. Because if you use, it depends on what type of technologies you use. If you're using pyrolysis, for example, it breaks down your organics, the materials, to gases, pyrolysis gases and liquids, and leaves a significant amount of carbon behind. That carbon, in the form of char, could be a form of sequestration for carbon that is not biogenic. That carbon could be used for use of materials. The lowest value for that char is if you go and blend it with asphalt and improve the properties of paved roads using that, or using plastics. So you're doing two things. You're creating biofuels through that process, and you're actually sequestering carbon that is not biogenic in nature. When that's applied, when we do all of this, here's our situation right now in terms of, if you look at the waste, municipal solid waste greenhouse gas emissions related to that. This is the amount of, this is the greenhouse gas emissions related to paper that goes to a landfill. Paper is not instant. If you send plastics degrade over time, a long time, but paper actually degrades much faster and produces greenhouse gas emissions. So we have a significant increase in terms of reduction in greenhouse gas emissions from landfill, from waste, if we apply all of this technology. That's in the form of how many cars we remove out of the road, okay? Cars as in combustion-based cars. So what are the challenges really applying all of these technologies besides the business as usual? The technical challenges is that the waste feedstock is really variable in composition in nature. Also, we have contaminations when we deal with thermochemical conversion and using catalysts to make biofuels from that non-recyclable portion of plastics and paper. We're dealing with contaminants like sulfur and chlorine, which are poisonous to catalysts. And they are the cause of many failures in projects in waste to fuels. in, in larger, even in biomass, not just waste. Hundreds of millions of dollars were lost because of these issues in contamination. So we have to develop technologies that are more robust, can deal with the nature of the waste. Economic scale limitations in conventional fuel cycles. So we have to develop technologies that not for the 50,000 ton per day, not for 100,000, for the 100 tons per day. This is the technology that we need to develop, because it has to be developed for distributed scale, for the small city, where we can actually produce biofuels, recycle or recover, achieve maximum recovery from municipal solid waste, to reduce the amount of waste that goes to a landfill to less than 10%. One solution that we have been working with is the pyrolysis. Why pyrolysis is a solution that could fit this specific problem, because choosing which equipment that you could use pyrolysis with, it fits the scales that we're talking about. For example, this system right here that I'm just showing, that has a pyrolysis reactor that's based on indirectly heated agar reactor. This could process about 100 ton per day. The 100 ton per day, without having to convert to biofuels, just conversion directly from pyrolysis gas, hot pyrolysis gas, directly into a boiler and a steam turbine, you can generate electric power. Bio-based electric power. Without having to use catalyst, without having to use complicated technologies. Pretty straightforward combustion system that could produce bioenergy with the highest levels of emission standards. Because problem with bio-based gas that that has a feedstock which has nitrogen is going to produce NOx. But the solutions for that are available and off the shelf. So you can have scrubbers, you can have all of this equipment that will fit this scale at a high economic value. So you can produce 5 megawatt of electric power at a distributed scale that make a huge difference in terms of local communities, especially communities that have bioenergy-based generation incentives. So I don't have a lot of time to talk about this, but this is just an overall mass material balance for a typical 1,000 ton per day integrated material and energy recovery facility. If you do it right, you design your MRF with maximum recovery. If you have the anaerobic digestion and composting, and you have the thermochemical conversion using pyrolysis, you can achieve maximum recovery either through perhaps existing technologies of electric power generation, like I talked about, or for advanced catalyst type of biofuel cycle where you could produce maybe sustainable jet fuel or diesel using a more robust catalyst. Thank you.
Thank you, Dr. Alyaser. Do we have any questions? Do we have any questions for Dr. Alyaser? Yes. We have a microphone on the room too.
Is this on? Thank you for your time. Question I have, you talk about bioplastic is really more of a renewable, falls in that category within the state of California. You're talking about pyrolysis also. Are you aware of the different laws or the legal terms for pyrolysis in California? Are you proposing this for California? Because pyrolysis take you 3 to 5 years to get it approved in any one single community.
Yeah, I understand the legal issues and the impediments and the perceptions that are created around pyrolysis. But I think much more open conversations about the technologies and explaining why should they be restricted in this nature, and why, and what is the drawbacks about them should be open. I think that there is wrong perceptions that are being created, which are creating impediments really in solving a significant problem. The amount of non-recyclable waste paper and plastics that we generate in the US is about 60 million tons per year. If you take that, the equivalent energy content of that is equivalent to 1 million barrels per day of oil. At the price of oil today, that's equivalent to about $10 billion a year. $10 billion a year, enough, I mean, just a portion of that can capitalize a lot of this investment in so the bioplastics you mentioned, yes, it's great, but at the end of the day, we need some sort of recycling. So you know that we've been talking about biodegradable plastics and all, and people didn't turn out to be as biodegradable people thought. And then no matter what, we need to have effective technologies that actually can chemically recycle materials that are not directly recyclable, whether it's bio-based or it is fossil-based. It'd be great if it's all bio-based. Wonderful, you know. We don't have to sequester it anymore. We just can convert it to biofuels or biomaterials or whatever, you know, but it has to be, we have to have effective technologies that can convert it. Pyrolysis, I don't know why this perception about pyrolysis that it can't be approved in California. There has to be a much more open conversation about that.
Yeah, the pyrolysis portion, it's a 20-year-old. These are 20-year-old laws that the verbiage was put in because a few bad actors 20 or so years ago came out and started doing this, and the state then created laws that made it very difficult for pyrolysis. So it's going to take it. I've dealt with Mark DeBee up at CalRecyc. It's 3 to 5 years with his legal team just to get approved for pyrolysis, because the in-depth it takes to go to the community and votes within the community, the residents, the outlying cities. This takes years to get done for pyrolysis.
I understand. We understand California is the 5th largest economy. It's an important place on earth, but it's not the only place on earth. We can go and prove it everywhere else and then show California that how it's done.
If we can get them to change that, the law, the verbiage, we'd be in great shape, but it's a hard push in this state.
I think right now, as you can see, what's happening, the governor just issued sort of like a plea for, please generate electricity. We need power, we need this, we need bioenergy. And the driver right now is that, okay, we have a resource. We send 600 tons per day from the Bay Area 2 hours away to a landfill of this material. You know, the harm that material is causing much further than any pyrolysis plant can cause.
Yeah, you're dealing with a fugitive emission issue. When you're dealing with, like, say, South Coast AQMD, which is probably one of the toughest in the world, you're going to put your numbers forward based upon whatever their classification. You're dealing with a fugitive emission number, which you can get very low. You can slip well underneath their threshold. It's some definitions to the state portion. And landfills themselves, a MRF, their first pass, their single sort, they're dropping 100 to 200 tons a day per facility of a commingled plastic paper stream. And they don't have time to pick it up and do it again. So this is going mixed in right with their solid waste going right to the landfill.
Correct? Yes, yeah. But I think the timing is, it seems that we are at the right timing for change, for much more open conversations that are based on scientific facts, not emotions that are with all facts. You know, when we talk about pyrolysis technologies and that, okay, so what does that mean when you do pyrolysis? Does that mean that you're going to release emissions? What pyrolysis? There's so many ways to do pyrolysis. Yeah. Yeah.
Okay, thank you very much. Very good, very nice presentation. Good question. Thank you so much. When we review abstracts, when we go through all the presenters and speakers, there's always something that catches my attention, catches our attention, and the next presentation we'll talk about, Mr. Dale Haase will talk a little bit more about his area of expertise. But what caught my attention was the keyword here, the key phrase, forgotten manufacturing hubs. I live in Chicago, so I drive just about every other day through what I would call forgotten industrialized hubs. It can be a heartbreaking experience at times. So I was especially looking forward to Mr. Haas' presentation. Mr. Haas, the microphone is yours.
Thank you. It's a pleasure to be here. I guess welcome to sunny San Diego, where the weather's always perfect. I just finished a week at a South Carolina beach where the weather was somewhat perfect if you don't mind melting most of the day and you like stepping on stingrays. I'm going to do my best to do honor to those forgotten communities. I want to start with just letting you know a little bit about who I am. I'm a project manager with SCS Engineers. We're over 51 years old, and we've specialized in, you know what? I need the clicker, don't I? There we go. We specialize in solid and hazardous waste management, renewable energy remediation, and environmental compliance. SCS Engineers has one of the largest and most successful biogas practices in the United States, primarily in landfill gas to energy. We have either completed or have underway over 50 biogas design construct plants and landfill gas to energy projects. And we currently operate or have operated over 30 biogas plants. So I'll say it flat out. SCS does know waste to energy. We know a little bit about that. More locally, there was a Central Valley dairy digester gas to renewable energy. We have more than 4,000 landfill gas and leachate projects going. I'm not an expert on either landfill gas or biodigester gas. If you want to know more about that, you need to talk to Pat Sullivan here on the West Coast or Bob Eisenberg on the East Coast with our people, and you can find out how to get in touch with them, if nothing else, at scsengineers.com. Now let's get on to the topic. Sorry, rushed through that, now I'm going the wrong way. All right. Oh, I did want to say one more little thing. Is there a pointer? Yeah, look at there. SCS was rated by Engineers News Record as #1 solid waste consulting firm in the U.S. So we know a little bit about this stuff. I just wanted to point that out to you. Now, on to the topic. We are, if I can get this to where I can use it. Honestly, the most time I spend in front of people is when I'm lead singer in a rock and roll band. So if you don't mind, I'd really rather sing this to you than say it. Is that okay with everybody? I'm just kidding. I don't have my band with me. We are in a renewable energy boom. We have seen a tremendous increase. 90% of the growth in the energy sector in 2020 was renewables, wind and solar. At times, when all the stars, well, actually when the sun and the wind align, we can produce more energy than we can consume through renewables. It's a tremendous thing. California can produce more energy than it can consume in renewables when the sun is shining and the wind is blowing. We can generate as much energy as the sources we're replacing. You know, we're shutting down fossil fuel plants, we're shutting down nuclear plants, and it's a good thing. Excuse me, it's a good thing. We should be looking to renewable energy sources, right? There's just one catch. Our grid. You guys ever been part of a rolling blackout program? Do you know why we have rolling blackouts? Anyone? Couple reasons. Back there, yeah. There you go. In the middle of the day, we can outproduce the nuclear power plants with solar energy and wind because everything's kicking, all right? But we have an aging power infrastructure. it's not capable. It was designed many, many years ago. Most of the power transmission lines we have are more than 40 years old. We have an aging power infrastructure. We have an aging grid, and it's incapable of handling the amount of energy we want to put into it. As a matter of fact, we've got states, New Jersey, for instance, the waiting list is several years now to put renewable power resources on the grid. So as good a solution as that seems to be, you know, we might kill a few birds or something or generate some noise we don't like. And with the photovoltaic cells and the wind turbines, we're also creating waste we're not sure how to dispose of properly, but we won't talk about that part of the problem. We are generating a lot of clean energy. What's another problem with solar and wind? I've got a point up there, but you have power when the sun is shining. You have power when the wind is. But what happens when you get into the doldrums and you need lots of power? Well, good old, what's one of the big California power producers? I'm not a power guy, so. There you go, PG&E, okay. Good old PG&E's nuclear plant went down years ago, took it offline, didn't need it anymore. So we don't have that big, you know, we'll call that the big battery that used to supply the grid. It's not there anymore. And what if you're way out in a formerly industrialized area where the grid hasn't been kept up to speed? You know, all that solar, all that wind is not going to get us there. We don't have the load balancing we need with all the variable inputs coming into the grid, all that power at once. You know, we're creating situations where breakers are tripping, you know, where overload circuits are tripping, or they're just having to shut down that power. So we've got a lot of power. Now, one of these days we're going to find a way to store all that, right? But for the time being, we have about $2 trillion worth of expenses we need to bring our grid up to speed to be able to handle the variable inputs. And that just hasn't been spent. I will say, to balance that out, we're going to spend that money anyway, just replacing what's deteriorating. Why not have a forward-looking plan? But that's not what I'm here to talk about. You need power when you need it. When power demand peaks, supply is waning. 5 o'clock in the afternoon, the hottest, kind of all the heat loading of the day comes in on you. Air conditioners kicking in, or 5 o'clock in the afternoon, sun's going down. You live in the Northwest, or you live in North Dakota, Montana, whatever. Sun's going down. You need to kick in the heat, and the power supply is waning. There's not much solar. Maybe the wind's kicking up, but it's very cold out. You need power when you need power. Manufacturing, especially, requires constant, reliable, resilient power. And unfortunately, until we have a way to store all that energy we can create with solar and wind, manufacturing can't rely on that energy day in, day out to continue to create. That's why, because of our aging grid and infrastructure, that's why we don't see manufacturing investments in some of those areas like Chicago. You've got communities missing out on opportunities because we don't have reliable power supply. We don't have the infrastructure to support it. They're going where it is or where it will be, maybe to the Sun Belt. Eventually, we'll solve the storage problem. You know, we've got the hot salt solutions. We've got maybe battery storage. That'll get better. You know, maybe we learn how to pump water up a hill and let it come back down again. I don't know. Maybe we learn to extract more clean gases like hydrogen. Maybe we finally crack the fusion problem and we get all of our energy from little suns all over the world. But until then, SCS has teamed with Green Worldwide to present Green Worldwide's thermolytic oxidation technology. Okay, here we go. We're going to talk about waste combustion again. However, Is it Alyaser? Dr. Alyaser has pointed out a huge problem. We're putting all kinds of waste in the landfill that have other great uses. For instance, we can pyrolyze it and turn it into fuels and raw materials. Great solution. Another solution is to be able to take some of these wastes before they go to the landfill. Take some of these wastes directly from the industry that's manufacturing it and place this green worldwide technology in that industry. Green worldwide technology provides a turnkey ready system. Basically, we slide it in on a pallet ready to go depending on the needs, depending on the fuel. It's efficient. It's right there locally, providing power to the manufacturer. They're using their waste. The manufacturer is able to use their waste chopped up a little bit to make it work. I'll just explain the system in a minute. It's able to provide combined heat and power, so it's very effective. You've got power and you've got steam, or you've got power, steam, and hot water as you need it. It's environmentally responsible. We're keeping waste out of the landfill, especially waste that are problematic. We'll talk about that in a minute. It's scalable. We have systems that we can develop from anywhere from 2 to 8 megawatts. That's enough to power manufacturing. That's enough to power communities. And I'm going to apologize right up front. This is not my way of building a PowerPoint presentation. I stole some of this from my partner, who was actually supposed to make this this presentation, and had to throw it together in a hurry, I'm afraid. It's robust. The plants that we have installed around the world, we don't have in the U.S. I'll talk about why that is in a minute. Have been running for 20 years. They have demonstrable great track records. It's innovative and disruptive. We can take all kinds of biomass and we can make usable energy with it. For instance, municipal solid waste. I'm not big on using municipal solid waste because I don't think that's where the heartbeat of this is. The heartbeat of this is using waste from the industry that generates it in the industry that generates it, reducing tipping fees. It's a niche solution, but it's a niche solution that can be good for industry, and it can be good for those neglected communities, the communities that can no longer survive without industry. Could be used tires, could be difficult to recycle, difficult to reuse plastics or textiles, auto fluff, used oils. We had one industry that we're still in negotiations with who has a pallet infestation. Are you guys familiar with the pallet infestation problem? What do you do with tons and tons of pallets that nobody wants? Well, you stack them up in the back parking lot, right? And they just sit there and rot. A quick overview of the technology. I'll show you some pictures of the actual technology. We use the old proven concepts of time, turbulence, and temperature. It's a high energy vortex that keeps the materials fed to it recycling. It can handle gases, it can handle solids, it can handle liquids. These materials are cycling with each other as the materials oxidize. They transfer remaining heat to incoming materials. Nothing leaves until it's thoroughly burned, thoroughly oxidized. We use the waste heat from that to heat water or to turn a turbine. One of the beautiful things about it is it's the isotherm across the entire range of the system of the combustion vortex. Or I should say it is an isotherm. It stays right at that 11 to 1200 C mark. Just another instance. It has low thermal inertia. It also has no moving parts, essentially, other than the blowers that keep it going. So you've got a system that you can bring up to full temperature in less than 30 minutes, depending on the fuel you're burning, and you can bring it back to where you could work on it in 30 minutes. It's all stainless steel, no moving parts, high efficiency combustion. So you can generate a lot of heat from that at temperatures well below where you're producing a lot of NOx. And I'm not going to start geeking out and talking about air pollution because that's an area of my specialty. How are we doing on time? Okay, just a quick overview of the layout. And this is sorry about that. This is designed to sort of allow maybe different kinds of waste collection facilities. But again, primarily what we're looking for is industry that can use the waste they're generating within the scope of what they're doing. So you'd have a reception area, a shredding area. We've got to get these solids down to about a 2-inch diameter, give or take, 2-inch grid size. Then you've got the thermal processing, and then you've got energy generation. Granted, what you're burning, what you're oxidizing, what you're thermolytically oxidizing is what we call it, may produce some gases depending on what you're doing. Tires is one of those things that takes a little bit more treatment, where you're going to have to do something with the gaseous emissions. We can handle that with scrubbers and baghouses, the typical air pollution solutions. Very clean overall burning, though. And finally, you've got that energy generation you're looking for. Again, 2 to 8 megawatts, depending on the need, depending on the fuel. Somewhere around 30 tons an hour capability. And we're not moving. Where's the laptop? Now we're moving. All right. Real quick, again, I don't want to geek out. I'm an air guy, so the first thing I wanted to do is compare tested emissions from these systems that we have set up in Japan, in Spain, in Mexico, and India. Emission testing that we've reviewed against U.S. standards currently, either the air pollution SISWI standards or other applicable standards, and found that we're able to meet all the or surpass all those standards. Just a similar slide. So we can handle waste from industrial complexes, municipalities, local governments, the food industry, oil industry, hotels and buildings, chemical industry. All these things that would be going to a landfill would be charged tipping fees, would have transportation to the landfill costs. Now you're taking that, you're using it as an energy in a very efficient system to generate power, to make the grid more resilient, to bring life back to communities that are dying because they're at the end of the grid, because manufacturers aren't interested in those areas anymore, partly because of that. And finally, you've got state-of-the-art components. The whole system would fit into something about a quarter the size of this room, except for maybe the air pollution control stuff. But we're talking about a very, very clean, very efficient system. It's not pyrolysis. It's not pyrolysis. We're not creating a burnable gas. We're not creating a gas that makes raw materials. We're trying to be very efficient with this for those niche places, for those niche industries, for those niche areas that just need to be able to create reliable power with existing waste in a way that makes sense. And we've got state-of-the-art controls on it. We can control airflow, we can control speed of rotation, we can control dwell time so that we can ensure we're getting the maximum efficiency with the lowest combustion emissions. And we really do believe this system is just one more step in helping to reduce waste going to landfills, helping to find a way to look at that waste not as a waste, but as a raw material or as a resource, looking to find a way to revitalize and sustain, if you will, the grid until we can upgrade it to the point that these communities that have been long overlooked can be looked at again by manufacturing. This is a solution that gives them an opportunity to be able to do that. So that's what I have for you.
Do we have any questions? Okay. Okay, we have a question.
Hello. It's actually two questions. One, does your technology produces char? And the second one, if the locations put in this technology, do they need a solid waste permit?
Okay, that's a good question. One, no, it does not produce char. It does produce ash, though. You are burning things that have unburnable things in them. So we will produce ash, but will not produce a char. Two, will the facilities using this, depending on whether or not they're taking municipal waste or industrial waste or other wastes from others and using that as their resource, or whether they're using their own waste as the resource. Two entirely different things. They should not need a solid waste permit because they're using their own waste as a resource.
Just another comment, what you were saying before, in the beginning, before you got to this very interesting technology, a lot of in the grid with the new electro vehicles coming out,
Oh my.
and that is going to put enormous troubles with the grid out there right now. And everyone wants to go with EV, and how are you going to do it? And so it's another thing you're saying to let's fix our grid now too.
Absolutely. Before we get too far ahead of ourselves, it's like the city that grew too fast for its roads.
Yeah.
We've got all this technology, but we're growing too fast for the road that feeds it. You're absolutely right.
Hi there. You said that the system generates between 2 to 8 megawatts. With that being said, can you speak for a second to what you've encountered with interoperability with the grid, or are you envisioning entirely reutilized at that facility only, or how? Because it seems like that's a lot of energy and the amount that any one facility may need, whether or not you're going to have overflow. So I'd like to know how SCS has encountered that
Sure.
that interface.
And you raised an entirely different can of worms. That these are great worms. These are fishing worms. I'm from South Carolina, so I'm going to use terms like that. Is that okay, y'all? Okay, awesome. Yes, many of the facilities we talk to, and we're still in negotiations. You know, it's hard cracking through because we don't have one in the U.S. yet. Okay, just you understand that. It's not sexy because it's burning. Okay. But we like to think of it as doing the same thing the waste will do in the landfill, only we just do it on a shorter term basis. Now, as to let me get back to your question. Sorry, I'll roll on all day. Yes, it's very integral with the grid. As a matter of fact, one of the things we envision, you know, for these left behind communities and these communities that are struggling, is to be able to microgrid them, so that manufacturing is interested, hey, even if the power goes down, I'll be in resilient power situation. I'll be in a situation where these are scalable, where you could have 1 unit, 2 units, 3 units, 4 units, and you can actually be generating a microgrid that's totally integrated with the grid, but with switches where you can island if you need to, and just generate for the areas that you're set up to produce for. So absolutely. Not here in the U.S. I wish we did. We're working really hard on that. And that's part of the reason we're here, is to get the word out, and hopefully, again, it's niche technology. It's not for everyone. Pyrolysis is the solution for some. You know, there are a lot of different solutions, but this is niche technology that I believe for certain manufacturing, again, wood infestations, tire rubber infestations, those facilities can use this to do a lot of good. Or this could do a lot of good in an area that's interested in taking that on and, again, developing a microgrid and bringing communities back to life for manufacturing.
Yeah, I think you could use that probably at the North and Central Valley for your farmers. They could probably use that if you're burning that. Now, I assume, looking at your graphs, that's more like a modified blast furnace. And
Yeah, you could call it that. Think of it. Are you familiar at all with air pollution technology or control technology?
Some of it, yes.
A cyclone, you know, where you've
Yeah,
got
your
something very
catch, your
similar to a cyclone that you're combusting in, only it's a much higher tech cyclone.
Now, how are you firing that off? What's your source of heat? Is that a flame heat?
Your,
Are you
your initial source,
recirculating that
your
gas?
initial source of heat is going to be natural gas or oil, something to get it to begin the combustion. Once you've got combustion going, though, within 30 minutes, you're auto-igniting,
And then-
completely auto-ignition.
The last question would be the heat recovery off of that. Are you recovering all the heat, or is that thing giving off heat like, say, a turbine engine does? Because that's going to be some of your air quality issues.
Yeah, that's the issue. We're recovering as much heat as available to recover from the waste heat coming off of it. It's highly insulated on the inside, not in such a way, you know, it's not ceramic brick and that kind of thing, but we're recovering heat from the wrap itself using water coils. We're recovering heat from the waste heat exhaust coming off it. So we're, I don't know, 80-something% efficient, which for a unit like this is probably 80 to 90% efficient, probably as good as we get.
And you transfer that heat to where?
We transfer that heat to either a boiler or to a turbine, primarily a boiler. We use that boiler to generate steam. And, you know, the boiler technology, you make heat, you turn it into steam, you transfer it to electricity, you're 33, 34%. That's about as good as you get from steam to electricity. I'm not a power expert, so I've probably already committed blasphemy somewhere in there. Sorry.
Okay, thank you very much, Dale. Another very good presentation, thank you. Without a doubt, the energy infrastructure in the United States could use some investments and upgrades. Thankfully, there's some good developments on the federal level, but if you represent a municipality or a business or an organization, you don't have the luxury of spending trillions of dollars with a stroke of a pen. So it makes perfect sense to squeeze the most out of the existing infrastructure processes, improve them as much as possible. Michael Drolet, Vice President of Product Development from TORXX, I believe he will touch a little bit more about that for us. Michael, mic is yours.
Good afternoon, folks. We're not burning anything, so let's put this aside. Perhaps I want to piggyback on both speaker things, saying they both been clear about one thing is the actual structure to recover material. You need to scope out as much as it's already usable in the network. You need to scoop out as much organics you can, send it out to the compost track. You need to scoop out all the recyclables, send it out to the recyclable tracks. For one simple reason, those tracks are already there, already existing, and already some pretty efficient. But what we realize over the year is there's more and more, the waste characterization is getting worse and worse, if I can put it this way. Especially with all the mixed MRF facility, they're at front line. They're getting all the MRF from the residents, all the material from the residents, and it's getting more and more contaminated, or more and more the mix is really changing, which create over the years, especially for the systems that are older, the problem that they can't keep up at discarding the organics, most of the organics from their system. They used to screen it out and it was clean. They use the same screen that they were using years ago, and now it's not even usable. They can't send it anywhere, and they're down to send it to the landfill. So what we end up developing is it's kind of an attachment to an existing facility to scoop out more organics that they are able to do right now. So basically, we're using our pulverizer as the core of the system to capture all the previously discarded dirty organics, right? And most of the mixed waste facility in the U.S. right now, what they're doing, and they make a first cut of tromoline material, hoping that all the organics will come out in the small material fraction, 0 to 2.5, 0 to 3 inch, they attempt to screen clean organics by 3/8 cut, but they end up with a pot of material that it's a mix of organics in, they end up with a mix of organics, plastics, film, foil, glass, that they can't do anything else than send it to the landfill because it's not usable, it's high moisture content. So it's become more and more a big chunk of their volume. So by processing that material through the pulverizer, what we are able to do is condition the material in a way that we can separate the organics from the non-organics material. So basically what happens in the machine is the ductile material will not size reduce because it's too soft, and we're using, we're not cutting the material, we're not hammering the material, we're just using aerodynamics to create cyclone inside that creates, again, matter against matter material. So everything that is brittle will shatter. Everything that is soft or like a piece of foil, plastic film, things like that, it's just gonna get released through the discharge of the machine intact. So once you get to that point, you just come and screen both fractions. We're just screening what's being processed. So here's a video that will illustrate what I just said. It's a tag on to an existing MRF, and that shows you the process that I just described. So basically, we have the TORXX itself, we have a settling chamber, dust collector to control the dust because the process will do. So that's your feedstock, which was typically sent straight to landfill, which can be up to 15, 20% of their inbound was that material because it's heavy, it's damp. So we feed the material to the TORXX itself to condition it so it will liberate the organics, size reduce the organics, will shatter the glass to sand or silt, so it will no longer be a contamination. And from there, we go to screening device. In this case, we're using oscillation screen, a Revitalization screen, but it can be any type of screen that came. So you see all the overs. That's the material that's not passing. So you see a lot of foil, paper, plastic film that are discarded, while what goes through the screen, it's compost compatible material. It can be mixed with compost, sent straight to a composter, can be used to land application, can be used to multiple. So that address, for all those facilities, it does address the new regulation, which, if you guys most likely know, by 2023, we have, in California, we have to cut at least 50% of the organic disposal at the landfill. And that's a big problem for all the operators because they know that right now, if they don't do anything, they won't achieve that. So that's an option to let them achieve that. So you can see what was the material before, which is not usable, and what's after. To tag along again with the previous speakers, what we also, and again, it's all a matter of transport, but if you're in a zone or an area where you have RDF or SRF facility, the overs from that process, perfect for SRF. That stuff can be blended with any RDF material, and its high calorific value because it's plastic film and it's plastic paper and it's diapers and it's stuff that has a good value for the RDF. The machine itself, I mean, we tested and we had application in numerous other things like whether if it's for gypsum, shingles, MRF fines, typical MRF fines with a high content in glass, to create sandblast media, for instance, using glass coming from MRF. But we'll be here. We'll be here today, tomorrow, and Wednesday. My colleague Terry Ward's with me. If you have any more question about either the organic process or the machine itself, just come see us. Thank you.
Thank you very much, Michael. Are there any questions? Is everybody ready for the reception? Okay, thank you. Michael, Dale, Dr. Alyaser, thank you very much for your very informative presentation. This has been great. The first session, the first pre-conference workshop, we never know how many people are going to attend, but this was great. Great attendance, good questions, and we have about 10-15 minutes break right now to relax, and we will, at 5 o'clock, we will start the reception at the Cabanas.
Well, hang on one sec, Norbert. If we
Okay.
could do this, I mean, we got a small group, and I actually want to start the networking right now. I'm going to ask everybody to give us, a quick introduction, because we don't have much time. But I just want to go around the room so we can start the networking, so everybody gets a chance to know each other when we go over here for the reception. Yeah, I'm going to start with you, Dan. You're sitting right there. So, real quick, who you are, who you're with, and what you want out of the event.
Oh, boy.
Who you are, who you're with.
I'm Dan Fowle. I'm with Shell. And I'm here because we're looking for waste plastic feedstock.
Glenn Tobiasen in Awakon. I'm also here in the next room, or in our display room with a thing, our display. And I'm looking to talk with some of the gentlemen here and also in their different displays and try to find out different things what we can do with MSW.
Just go around.
Hello, everyone. I'm Brian Johnson with Now On, and I work with a company. Our company does thermal hydrolysis of the organic fraction of MSW, which is somewhat rare. So we're hoping to meet people in the AD area, diverting organics away from landfills. So.
Gotcha. I'm Daniel Kleski. I'm with PrintPack. We manufacture flexible plastic packaging. I work in our recyclability group, so I'm interested in learning more about plastics recycling and where that might be in, not the next coming years, but sort of further on down the line.
Hi, I'm Cristina Valle-Park. I'm with California Recyclers and Edwin Fuels. I'm here to create synergy, learn from others, and see what's coming.
Travis Park, California Recyclers. We're here just touching and again see what's going on, make sure that the technology we've developed is running in the right direction. Maybe meet some new people, see what can happen, find out what Carlos is doing over there at Now On. That's what we're doing.
Hi, good afternoon. My name is Natalie Van Dyke. I'm with a company called Electrotherm. We do organic Rankine cycle generators. This is the first waste conversion anything of any kind I've ever been to, and I'm here to rob you all shamelessly of your intellectual capital.
You got to love somebody that's honest.
I'm David McConnell. I'm with Georgia Pacific. I'm here to present Juno technology and really to understand all the new innovations that are coming out and just kind of stay on top of that.
I'm Bernard Brown from Nexus PMG. My background's thermochemical conversion technologies, and I just wanted a free trip to San Diego.
I guess I paid for that trip. Roshan Vani, Nexus PMG. We're independent project developers looking to learn about different solutions in the market.
Now, are you Nexus that's out of Atlanta, or is that a different company? It's a different one. All right, so there's a Nexus. Okay. John?
Hey everyone, John Carlton with HDR Engineering. We advise mostly government clients on and project development and design. So I'm here to understand the latest in technology.
Hi, my name's Bill Embry. I'm from Pinellas County, Florida, Department of Solid Waste. We have an integrated solid waste management program which incorporates waste energy, landfill, tires, and chemical recovery. And I'm curious to see, and we've just completed about a 30-year solid waste master plan, so I'm curious to see if there's new technologies that might be applicable to our future.
Great. Bill, we got to come all the way to San Diego to meet each other.
Good afternoon, everybody. My name is Akeem Carr. I'm a student pursuing my bachelor's at Everglades University in Renewable Energy, and I'm here because waste conversion is something I'm really interested in.
Delighted you're here, son.
Terry Ward with TORXX Kinetic Pulverizer, Michael's partner, and I'm here because after dating myself, 30 years in the business, I'm still extremely passionate about converting these unusable fines, whether it's C&D, whether it's from single stream, whether it's coming out of mixed waste, into something that has a beneficial use. And I hope to talk to folks about that this week.
I'm Jason House with Demcon Companies. We're a family-based, facility-based company out of the Twin Cities in Minnesota, and I've attended this conference probably 7, 8 times already, and my goal each time I come is to try to look at new technologies so we can develop our campus into a fully integrated facility where we can handle every type of waste that comes to us, as well as reduce the amount that goes to the landfill.
Hi, everyone. I'm Teresa Rademacher. I'm with the Solid Waste Association of North America, and I'm here to see what everybody's doing and kind of facilitate some conversations.
Thank you, Gene. Just want to let you know this is one of my favorite conferences every year, and it's probably about the 5th or 6th year that I've attended. I run the Imperial Valley Economic Development Corporation. Imperial County is just about 2 hours from here. And what I hope to get out of this is to learn new technologies, meet new people, network with you, and show you how to do projects in California.
And I think you'll take a site, too, if somebody wants to put a facility.
I'm Emily Dyson. I'm with BioHigh-Tech. We are the majority owners of the first high-efficiency biological treatment facility in the U.S. We started making fuel about a year and a half ago, and it's a really high-quality fuel. I'm here because I think we have a really good product to take to gasification, and I want to learn more and kind of extract from everybody their knowledge and walk away from here with some possible new contacts.
Nick Vetch with Foth, just looking for the latest and greatest MSW solutions.
I'm Gary Smith. I'm from Baker Commodities here in Los Angeles. We're looking at the latest updates in technology for waste conversion, and we're also looking at what technologies might help us reduce any of our waste streams and turn them into profit streams.
My daughter, Taryn Knight, over here, David Palka, and Tim, what's your last name again? Carr. So these are the guys that are driving the train from the AV perspective. I tell you, after doing these virtual hybrid events, I don't want anything to do with this. That's why those guys are here. All right, folks, that's going to conclude our workshop for today. Reception is over in the cabanas. We're a little bit early, so we'll start about 5 o'clock. If some of y'all want to stick in here and network, that's fine. Otherwise, go up to your room, put your stuff up, and come on down and have some cocktails, and then we'll kick off tomorrow morning at 8:30.